Hello everyone, this is video 9 in my series of trying to use Google's Gemini 2.5 Flash with a custom gem to try and learn the NIM programming language while solving problems off of Project Euler to actually do the learning. So this is problem 9 in the series, and the previous videos are in the playlist. And do check out the description of the video if I do put useful information in there. So let's go through our routine. Let's take a screenshot here of problem 9. Okay, so, all right, what is this? Oh, that's a bit big. Okay, so what does this say? A Pythagorean triplet is a set of three natural numbers. A is less than B is less than C, for which A squared plus B squared equals to C squared. Okay. For example, 3 squared plus 4 squared equals to 9 plus 16 equals to 25, which is 5 squared. There exists exactly one Pythagorean triplet for which A plus B plus C equals to 1000. Find the product ABC. All right, so this looks like a interesting math problem and not just adding a bunch of prime numbers. Okay. So I think what this is saying is fairly self-explanatory, but for any number A, need to stop doing that. All right, any number A, B, and C, we have condition 1, A is less than B is less than C, and 2, the squares of A and B are exactly equal to the square of C. An example is 3 squared plus 4 squared equals to 5 squared. So there exists exactly one Pythagorean triplet for which A plus B plus C equals to 1000. So I think programmatically this is plenty simple. I don't even know if I'll need Gemini for this. Well, I don't want to count my eggs before they hatch, but here, nvim problem 9.nim. One of these days I will figure out why my NeoVim needs me to do manual highlighting, but for now, let's work with what we got. At first, I think I'll give you guys a horrible solution, and then I will work on a better solution, a more elegant solution. So this is the horrible solution first. Horrible but straightforward. But straightforward solution. Straightforward. Okay. Oh, probably shouldn't have spelled the whole thing, but okay. The horrible but straightforward solution is a triple nested for loop. I know that's practically blasphemy, but I kind of want to see how well NIM handles something like this. So I'll just define a function that checks if the three numbers are Pythagorean. So to do that, we'll do proc Pythagorean func. Well, Pythagorean test. I don't want to define a proc and call it a function. So A int B int, which is how you tell the program that which is how you specify the types. This is how you specify the types of your parameters or your arguments. This will return a bool. So what this is really doing, this is just doing if A times A plus B times B equals to C times C, return true. Else or return false. So take three numbers, and if a squared plus b squared is equal to c squared, say it's Pythagorean, else it's not. So, and for shame, oh, go with a triple nested for loop. Oh, come on. Bool. Oh, 6GG. All right, so do for a in 1 to 1,000. I will do a better solution. I do have a better solution in mind, but for now I just want to tinker with nim and see how it does. Um, for b in 1 to 1,000, for c in if a plus b plus c equals to 1,000, Pythagorean test. If Pythagorean test a, b, c, echo a, b, c, or, well, yeah, and echo a times b times c. I think that should work because there's only one, and really we should really go down to this might make a tiny bit of a difference because it can't be 1,000 because one number can't be 1,000 because everything else will be 0. So do yeah, and then break. I think that's it. Right? So, but I will do a better solution. So don't hate me just yet. Nim. Did that work out? Okay, so problem 9. Okay. Ooh. 200, 375, 425, 318. So the three numbers are 200, 375, 425. That's kind of interesting. Huh. It did that twice. I messed something up. It should have done that only once, but the numbers are the same. So it wants the product. So let's see. And that's what our program generated. And we're going to sign in. Username and password. CAPTCHA is 90983. Problem 9. And problem 9 is, and according to the website, 3187500. So let's see one thing. Time problem 9. 1.47 seconds. That's 1,000 times 1,000 is a million, and a million times 1,000 is a billion. So that's a billion calls in 1.47 seconds with 4 printouts, 4 standard line printouts. So that's pretty good. That is pretty good. Um, I do want to do, uh, oh, I do, and this is what I wanted to do. And A is less than B is less than C. Expected one of. Oh, what did I do? Oh, and B is less than C. That's probably what it wants. Yep, that was what it wanted. Okay, so I think that solves my problem. Yep, that only printed it once. Yep, I should have. Yeah, so a couple of seconds, a billion iterations. That's pretty good. So brute force, that's pretty good. So we got one more. Oh, sorry, one more smiley face. Answer is correct, but I do have a better, more mathematical and not just brute force programmatic solution in mind. So let's try that. So let's do that. Okay, cool. All right, so the problem is saying A is less than B is less than C, and A plus B plus C equals to 1,000. So if A is less than B and B is less than C, and the three of these add up to 1,000, then so B is A plus something, and C is um, again A plus something else. So A has to be at least 1, and A A has to be at least 1. We know that. It can't be 0. So 3A plus X plus Y. Now, whatever the value of these, it has to be whatever the value. For now, what we can say is 3A is less than 1,000, right? So 3A is 3A is 1,000 minus X minus Y. So whatever the value of X and Y, 3A has to be less than 1,000. So if you divide by 3 on both sides, that comes out to be about 333, let's say 335, just for comfort's sake, just for convenience sake. So A can be at least A has to be at least 1, and it can be at most um, a little less than 335 because there is X and Y here. So we don't actually need to, in the first loop, we don't actually need to go past 335. In the second loop, so B is B plus C equals to 1,000 minus A, because A plus B plus C equals to 1,000, so B plus C, sorry, 1,000 minus A. This should be A. I am so sorry. So this should be A. So again, A has to be A has to be at least 1, and it can be at most something around 335. It can't be more than 335. It'll be a little less than 335, but it can't be more than that. And B and C has to be B plus something, Z maybe. So this is, so 2B equals to 1,000 minus, this is A, not a Q, minus Z. But but for now, let's kind of just heuristically drop B and Z. It has to be less than 1,000, and B has to be less than 500 if you divide by 2 on both sides, right? So if you divide by 2 on both sides, B can be at most, it'll be a little less than, because we can't really know what Z and A are. What we're going to do is eyeball it and say it's going to be less than 500. Now, the best optimization we can do here is actually not just 335 and 500, but the fact that C is dependent on whatever C is dependent on whatever A and B are, right? So whatever A is and whatever B is, C is already constrained. C cannot be anything other than what is determined by A and B. So C is not independent. So we actually don't need a third for loop, because if we have for A and for B, then C can be only one thing. So C can only be minus A, right? So I think, how about this, right? So nvim, okay, touch problem 9 better solution dot nim. So nvim problem 9 better solution enable highlight. So make it a little bigger. So I said an outer loop for A in 1, and it can't go, really it can't go past 333. I'm just doing 335 for the sake of convenience, 333.333, but I'm just doing 335 for the sake of convenience. And an inner loop for B in 1 less than 500. We should probably do var c int, because we need a placeholder for C, and that would be C can't be anything other than A and B, and there's still a possibility that C is less than, I mean, in this iteration, C might be less than B. Continue. If C is less than B, then don't bother with this iteration. Finally, if A times A, well, A square, really, B is equals to C square, then what we can do is echo A, do some spacing, B, do some more spacing, do C, and then echo A, B times C. So, unless I am hilariously wrong, should be able to do nim, and something I learned from a Good Samaritan is that apparently you can run a nim script while you compile it. So that would be um, uh, nim -d release. You can see my terminal trying to help me out here. Run problem 9 better solution. Okay, so yep, 200, 375, 425, 318, 750, which was the solution we got with our previous iteration as well. But our previous iteration took time. Problem 9 took, our previous solution took about, all right, give or take 2.56 seconds. Let's see how much time. Problem 9, which I think this is fairly impressive. I'm not unimpressed with this. 2.48 seconds, so give or take 2 seconds. I am not unimpressed with that at all. Problem 9, better solution. That was 3.77 milliseconds. Yeah, fantastic. So there we have it, a mathematically optimized solution and just a plain programmatic solution. Very interesting. Cool. See you guys in the next one, which is archives problem 10, summation of primes. The sum of primes below 10 is 2, 3, 5, 7. 2, 3, 5, and 7 equals to 17. Find the sum of all primes below 2 million. Doesn't look too interesting, but I'll see you there. See ya.